Hello everyone, I'm Morgan, a principal engineer at Nuvoton. It's been a while since the last tutorial on the NuMaker-IoT-M467 development platform and Mbed OS. Due to Mbed discontinuing the online development tool, Online Compiler, it has been replaced by Kaya Studio Cloud. The interface of Kaya Studio Cloud is similar to the offline development tool, Mbed Studio. We will learn how to use Mbed Studio with the newly released NuMaker-IoT-M467 development platform. First, let me introduce Nuvoton's NuMaker-IoT-M467 development platform. It features the NuMaker M467 microcontroller with an ARM Cortex-M4 core, equipped with 1 MB of flash and 512K bytes of SRAM. It has a built-in RJ45, 10 and 100M Ethernet port and Wi-Fi modules, providing both wired and wireless network connectivity. In addition to the board service pack, it also supports RTOS, such as FreeRTOS and Mbed OS. Before using Mbed Studio, there are a few preparations you need to make. If you don't have an Mbed account, please create one. Open your browser and go to the website os.mbed.com to register for an account. Hover your mouse over the person icon in the top right corner and click on Login or Sign Up. On the login screen, click on Create an account. Click on Sign Up once again. Fill in your email, username, password, name, country, and other information. Then, check your email to receive the verification email. Follow the instructions in the email to complete the registration process. Next, download and install Mbed Studio. Go back to the Mbed homepage at os.mbed.com, and in the top left menu, navigate to Overview and then Development Tools. Click on Mbed Studio. On the Mbed Studio web page, please choose the correct version to download based on your system. For this tutorial, we will be using the Windows version. Run the downloaded installation file, mbedstudio.exe, and follow the instructions to complete the installation. Once Mbed Studio is installed, launch the application. Let's create a new program in Mbed Studio. You can either create a new program or import an existing example. Here, we will use the import option as an example. Click on File and select Import Program. This will bring up the Import Program dialog box. Mbed samples are usually sourced from two websites, the Mbed OS official website at os.mbed.com and GitHub at github.com. In the dialog box, enter the URL of the example you want to import for this tutorial. In this case, enter the example URL as https://github.com/onmbed/embed-os-example-blinky. After entering the example URL, Mbed Studio will automatically populate the program name. The program name must be unique among all programs. If you wish to use different name, you can modify it accordingly. In this case, since it's the first import, there won't be any conflict, and there is no need to modify the name. Check the box that says backlist the active program to set this program as an active program. This means that after the input is completed, this program will be the one used for compilation, downloading, execution, debugging, and other operations. The Mbed OS location provides two options. The first is to store the Mbed OS source code in the program's directory. And the second one is to specify another directory to store the Mbed OS source code. When you have multiple programs, sharing a single Mbed OS source code can save hard disk space. Since this is the first import, choose to store the Mbed OS source code in the program's directory. Click on Add Program to start importing the example and creating the program. After importing the example, make sure that the active program is set to Mbed-OS-example-Blinky. Next, select the target development board. There are two ways to select target board. You can either choose it from drop-down menu or search for it by entering keywords. For example, if you enter N467, you will find the NuMaker-IoT-M467 development board. Click on NuMaker-IoT-M467 to set it as the target board. Alternatively, if you have connected the development board to your computer via USB, Mbed Studio will automatically detect the Mbed OS certified board and ask if you want to set it as the target board. Click Yes to confirm and set it as the target. Next, let's take a look at the example source code. Click on the file name and it will open on the right side. Please click on main.cpp to open it. This is a simple example that declares a GPIO output, digital output, corresponding to LED 1. It then uses a while loop to toggle the LED on and off, and wait for 0.5 seconds. Let's modify it to add the output Hello World inside the loop. In Mbed OS, the configuration settings are typically found in the Mbed_app.json file located in the program directory. If this file doesn't exist, the setting will use default values. For example, the default baud rate for URL output is 9600 bps. If you want to change it to 115,200 bps, how to change it? Click on File, then click on New File. Enter the file name as Mbed_app.json and ensure that the file is created in the Mbed-OS-example-Blinky directory. Then click OK. Next, fill in the content in the screen into the editing area on the right side. Next, let's compile this example. Click on the hammer icon to start compiling process. A flash compilation may take a few minutes to complete. Once the compilation is completed, the generated firmware file will be located in the build-NuMaker-M467/ARMC6 directory within the program's directory. The file name will be the name of the program with the extension .bin. Therefore, the complete file name will be Mbed-OS-example-blinky.bin. At this point, If you haven't connected the NuMaker-IoT-M467 development board to your computer, please prepare to do so. Pay attention to the SW2 switch on the new link to me located on the development board. Make sure that switches 1 and 2 are set to the on position so that the printf output can be sent to the computer through new link to me. When you connect the USB cable to your computer, a new micro MCU disk will appear. There are two ways to program the firmware onto the development board. 1. Copy the firmware file directly to the new micro MCU disk. Once the copy is complete, the programming is finished. Or 2. Click on the Run icon. Mbed Studio will then recheck the source code, and if there are no changes, it will proceed with the download process. After the download is complete, the development board will start executing the program. Mbed Studio has a built-in serial monitor that automatically opens when it takes a development board supported by Mbed OS. Since we have set the baud rate to 115,200 earlier, the serial monitor should also be set to the same rate to receive and display the data correctly. At this point, you can also press the Reset button on the NuMaker-IoT-M467 development board to restart the firmware. After the restart, you will see the LEDR on the NuMaker-IoT-M467 development board flashing, and Mbed Studio's serial monitor will continuously print Hello World. That concludes our tutorial on getting started with Mbed Studio on the NuMaker-IoT development board. We hope it has been helpful in getting you started. Thank you for watching. If you would like to learn more or have any further questions, please feel free to contact us.